So you should have just finished up watching the video where I showed you and walked you through the handout. Okay, this video, this one, I need you guys to set up in your notebooks. Okay, this is like your formal notes number 8. We're going to look at the transformations of absolute value functions. We're going to look at them to kind of review a little bit of what we've already seen, and I'm going to go over each one of these. At any point, feel free before I start, probably pause the video, copy the first two boxes because there is a lot of information here. I would copy them down, that way as I'm going through the video, then you can just follow along with what you have written. Okay, so try not to write and listen at the same time because there's a lot of information. Okay, so we're going to go back to the general form of the absolute value function. We have y equals a times the absolute value of x minus h plus k. We're going to spend time focusing on each one of these variables, which is a, h, and k. Okay, we saw a little bit about what they do in the handout, and I'm just going to go into a little bit more detail. So just like before, a determines direction. Okay, so if a is a positive, then the graph opens up. Okay, that's simple. If a is a negative number, then the graph is going to open downwards. Okay, the fact that it's a negative, it meant that it got reflected across the x-axis. Okay, so keep that in mind. Now, a determines two things. We already saw that it determines a direction, up or down, but a also determines whether something gets stretched or something gets compressed vertically. Okay, so here's what I have. If a, okay, I'm looking here and notice I put a inside absolute value. The reason why I did that is because, take a look at the example. Let's say, for example, that a is equal to -3. So let's say that a up here is a -3. Okay, that's going to tell us two pieces of information. The first one is that a is going to open downwards because of the negative. Okay, so we have the arrows pointing down. Now, the other thing that I want to focus on is the size of the number. Okay, so that's why I stuck that -3 inside absolute value, because I want to know the size of the number. Is it a big number? Is it bigger than 1? Or is it a small number smaller than 1? In this case, by taking the absolute value, that shows me that, hey, even though it's a negative number, the size is 3. And if I have a number that's bigger than 1, then that's going to cause my graph to stretch, which means we're going to pull it. It's going to become more narrow. If a is something like -3/4, so let me change it up here, right? Let's say it's -3/4, then we know two different things. The fact that it's negative causes the function to open downwards, so we're going to have a v that points down. But then, because 3/4, I'm looking at the size of that number right here. Since 3/4 is smaller than 1, then it's going to compress. Okay? So the reason I did that is because I don't want you to think that because it's a negative, let's say if it's -5, just because it's negative doesn't mean that it's going to compress. It's still going to stretch because 5 is a big number. But the fact that it's negative just means that it's going to stretch and the arrows are going to be pointing downward. Okay? All right. The rest over here is pretty straightforward, okay? Let's start with k first because that's a little bit simpler to understand. K determines vertical shifts, right? So if k is greater than 0, which means if k is positive, okay, if you add a positive number, then it's going to shift up. And if k is less than 0, if it's a negative number, then it's going to shift down. Okay, so that's pretty simple, pretty straightforward. Okay, and then finally, we look at h. The reason why I left h for last is because h has the trickiest part to remember, because you have to remember to use the opposite. Okay, so for example, let me go back to the general form, and I want to write some notes up here. If I have the general form as a times absolute value of x minus h plus k, okay, the reason why it says that if h is positive, you're going to shift to right is this. Let's say that the h I want is, let's say h is 5. Okay, well, if I were to take 5 and plug it into the function, here's what it's going to look like. Y equals a times absolute value of x minus 5. Okay, because h was 5, it was just a clean substitution plugging in here. Why is it negative? Because the negative comes from the function. That negative, you just have to bring it down. And then I have plus k at the end. Okay, so I've taught you before that you take the opposite of this number, right? You take the opposite of that number, and that helps you find your vertex, and it also tells you how many units you're going to shift in which direction. So the opposite of negative 5 is positive 5, okay? And guess where that came from? The positive 5 that h was equal to in the beginning, okay? So that's why it's backwards. So I have a positive number that I plugged in, but it's the function, the notation, this negative here, that when I bring it down, it makes it look like it's a negative 5, when in reality, it was a positive 5 all along. Okay, it does the same thing when you have a negative h. So let's say, for example, h is negative 3. Okay, if I were to plug that in, I would have y equals a absolute value of x minus, this is the minus that comes from the function. Okay, it's the same minus as this guy over here. Okay, these minuses are the same thing. But then because I plugged in negative 3, then it's parentheses negative 3, close the absolute value, and then plus k. So what happens with these two negatives? Well, you're supposed to clean up the inside of the absolute value as much as possible. So eventually this becomes a times absolute value of x plus 3 plus k. Okay, so in reality, h is a negative 3, but when you look at it in the function format, it looks like a positive 3. That's why we have to remember to do the opposite of what you see. Okay, so this right here is like a formal definition. Okay, I want you to remember whatever is inside, you do the opposite of that. Okay, so in this case, with negative 5, you're going to do the opposite. You're going to move 5 to the right. In this case, where you have positive 3, you're doing the opposite. So you're moving 3 to the left. Okay, that's all you have to remember. But I wanted to show you why it's the opposite and not the real number. Okay, all right. So for example 1, okay, we're just describing the transformations. Okay, you're not going to graph them because you know how to graph. We did that in the other lesson. You can create a table and you can do it quickly. Here, what we're looking to do is try to find out how can we describe the transformation using some of the language. So the language is very important because you don't want to just say like move left and move right, move up and move down. You want to sound sophisticated, okay? And the language needs to be sophisticated as well. So we have two different changes that are happening here, two different shifts. The first shift occurs, if you notice, inside the absolute value. We have a minus 5 here. So remember that we're shifting in comparison to the parent function. So the parent function is y equals absolute value of x, right? So we're always comparing it to this function here. So because I have minus 5 on the inside, remember that we're going in the opposite of the negative. If negative numbers are left, we're going opposite, so we're going to the right. So then that tells us we're going to have a horizontal shift of 5 units to the right. Okay, you want to write it exactly the way that I wrote it here. Okay, a horizontal shift of 5 units to the right. Okay, the second change that occurs is the plus 2, right? That's our k. Now, if anything happens to k, if any change happens, then it's a vertical shift. Okay, so I have a vertical shift of 2 units going up. Okay, so number 1 is pretty simple, pretty straightforward. Let's take a look at example number 2. Again, we have two different changes that are happening here. Okay, the first one, let's take a look at the simple one here. We have a minus 10 attached to the outside, right? It's a minus sign. So if it's minus, you don't go up, you go down, all right? So we have a vertical shift here of 10 units downward, okay? The other one is pretty simple. You can see it, that there's a 2 in the front, okay? So with that 2, remember that that represents A, and A controls direction and whether or not we stretch or compress. Well, since A, the number is 2, and 2 is greater than 1, then we're going to have a stretch. Okay, so the way that we write that is we have a vertical stretch by a factor of 2. Notice the language that I used here is very similar to the worksheet. If you have the worksheet in front of you, you'll notice that one of the examples, it said vertical stretch by a factor of 4 or vertical compression by a factor of 1/2. Okay, so I'm using the exact same language that we use on the worksheet. Okay. All right. Next one. This one, there's only one change to it. The change that occurs here is the negative in front of the x. Okay, because it's very similar to the parent function. Remember, parent function looks like this. So all there is there's a negative in front. Okay, when that happens, please don't say flip it over or it points downward. Okay, you want to talk about what really happened. What was the transformation? Well, the transformation was a reflection. Okay, it was a reflection across the x-axis. Okay, Another way you could also say was it's a reflection across the line y equals 0. And that's because the line y equals 0 is the same thing as the x-axis. These two guys are the same thing. Okay, so regardless, if you gave it to me one way or the other, I would understand it and I would accept it as correct. Okay, so that was pretty simple. There was only one change. And then the second one, I'm sorry, example number 4. This one's a tough one, okay? There's 4 different things going on here, okay? I might put a star next to this because you might expect to see one like this. So let's highlight the ones that are pretty easy, okay? A vertical shift of 7 units up, okay? I have a plus 7 on the outside. That's the vertical shift 7 units up, okay? Next, let's go and take a look at the 3/4, right? The fact that it's 3/4. I'm not looking at the negative. I only care about the fraction here. Okay, 3/4 is smaller than 1, right? We agree. So when it's smaller than 1, we get a vertical compression. Okay, it compressed the graph. It's going to be wide, right? So it's a vertical compression by a factor of 3/4. Okay, pretty simple. The next one, okay, we have a -2 inside. Okay, if it's -2, then that's a horizontal shift. Okay, the fact that it's inside makes it a horizontal shift. Now we just have to decide which direction. So since it's -2, you remember that it's the opposite of what you see. So since you see -2, you're not going to go to the left, you're going to go to the right. Okay, so we go 2 units to the right. Okay, and then finally, this one, it's a little bit hidden, but there's a negative right there. The negative, we just looked at it like in example number 3. The negative tells us that there is a reflection across the x-axis. Okay, so what happened to this graph? We shifted it up 7. We shifted it to the right 2. We compressed the graph, and then we reflected it across the x-axis. Okay, so those are the 4 examples I'd like for you to have. Okay, what I'd like for you to work on next is there is a homework that I want you to do in class. Start it in class. I want you to take a look at the homework that's inside the Unit 2 folder. Inside that folder, you have functions that you're going to graph, but not only graph, but explain the transformation. Okay, so with that, you can do a little table. If you need to use the back, that's fine. If you need to do a separate sheet of paper, I know there's not a lot of room on it, but I hope that this helps give you an idea of how to derive the transformations. Okay, to graph them, look back at notes number 7 and how to use the table. Okay, so there's 2 different things you can use together, but I want you to do both. Okay, I want you to graph them and I want you to write down the transformations. Okay, if you have any questions, feel free to send me a message. I'll probably still be available on my computer to reply to any questions you have, but I'll be at the training. Okay, so be good to the sub. Please stay on task, and I'll be back on Tuesday. And any questions that you guys have, we can go over in class then. Okay, have a good weekend. Adios.